Okay, today we're going to look at a problem that I've set for you, which is a two-dimensional array problem called box of ones. I've put it on Replit, and I'm going to try and work out a solution myself and show you the way that I would approach this problem. So, first of all, I need to read the problem, and it basically says create a two-dimensional array size 2020, print the array, so create a method to print the array, populate the array with either ones or zeros, and then print it again just to check that it's worked. Then after that, what we're going to do is we're going to count for each element. We're going to count itself and all of its 8 neighbors to find out if they contain a 1, and if they do contain a 1, then we'll add that count. So that's the first task. So let's start with this. So the first thing I'm going to do is I'm going to declare an int array, a two-dimensional array. And here I'm actually going to declare a constant called size, and then I'll make the array equal to row length, the number of rows size, and the number of columns size. Here I'll run this just to make sure that I've not made any typos, and that appears to work okay. So the next thing I'm going to do is I'm going to print the array, and I'm going to make a method called print array or print r, and I'm going to put my array in there like this. Now at the moment that won't work because I don't have a method called print array, so I'm just going to go below the main method here, go underneath this, and I'm going to make a private array. Now it's static because it's not associated with object-oriented programming. What does it return? It doesn't return anything, so it's void, and it's called print array, and the parameter that it takes in is a two-dimensional array, and I'm going to call it r here as well. I could call it something else, but I'll call it r here. Now I'm going to start with a little line just to say this is me printing the array. And then I'm going to iterate through the rows. And when I first started doing this, I used to think about x and y a lot, but it's really not a good idea. You should think about, in fact here, I think I'm going to say r, int r is equal to 0, and then r is less than r dot length. And if I just take a little bit of time here, it might give me the help, but it's not at the moment. So this is Replit that we're using here, and it doesn't always kick in quite straight away. But yeah, so I was saying that I tend to nowadays think about row and column rather than x and y, because if you think about x and y, you'll just get confused because it seems to be the wrong way round. C is less than, and here I'm going to say ri, so for every row, how many columns are there, or how many elements are there in that row, if you prefer. So this is me just being really accurate. Now you could turn around and say, well, it's a square, but that's okay. So here I've iterated through the rows, and now I've iterated through each element in the row. Just going to make that a tiny bit bigger so you can see it. And so what am I going to do now? I'm going to print out r So that should print it out. Mistake I made here was I used I because I usually use I and J. So here, there we go. And I've got that bit there. Now that's fine, that's going to print everything out next to each other. But at the end of every row, I want to have a new line. So I'm going to do a system out print line. I'm going to run that. Oh, I've missed out a semicolon. And that we can see here. Now the important thing here is that populates with lots of zeros. So you don't have to populate it with zeros because it does it by itself. I'm just going to put a tab in here. So an escape character for tab, just to make it look a tiny bit more presentable. And if I just zoom out there like that, run it again, and that looks fine. Okay, I'm just going to close that up for a moment so we can see our code a bit better. So I've done that, and that's the printout. Now the next thing is to populate the array. So I'm just going to do pop array here, or you could call it populate array if you prefer. It will be private again because I don't want it to be used outside this file, outside this class. It will be static because we're not doing object-oriented programming. This is a standalone method. This one is, once again, it's void because it's not going to return any values, and the name of it is called pop array, and it takes in a two-dimensional array, and here we'll give it a local name called R again. Okay, once again I'm going to iterate through each element. Okay, I'm not going to bother writing rows and columns just now, and I'm just going to call it I as well because I'm not too worried about it because I'm not printing out. I is less than R dot length I plus plus. So this is exactly the same as the print statement really, and you would be tempted to copy the code, which I could have done to save time. I'm using I and J this time, which is kind of typical. Once again, I'm going to look at the row length for this one. You could say it doesn't matter because it's a square, it's 20 by 20, but this way it will be a piece of code that could be reused for other circumstances. Now here, I'm going to populate approximately half with a 1. So how am I going to do that? So the way I'm going to do that is I'm going to do math, if I could actually type, math.random. Math.random will produce a value from 0 to less than 1. Okay, so if math.random is greater than or equal to 0.5, so that gives me half of the values, then what I will do is I will set the array value that I'm looking at the moment, which is ij, to be equal to 1. Okay, so that's what that should do there. If math.random is greater than or equal to 0.5, I'm going to change the value, that the array element that I'm looking at the moment, to 1. I can find out if that works by going up here, and I'll just do another print R, pass in the value, and I'm just going to make this a tiny bit bigger so you can see this, and we can see that looks like it works. I've got a bunch of random ones and zeros happening there. Okay, and I've run it a couple of times just to make sure it provides different patterns so I can feel comfortable that I've got it right. So that's the print method, which is really common. I've got the print statement inside the internal loop and a print line after the inner loop there. Then I've got my populate the array, and the way I've done that is I've generated a random value, and I've thought, okay, for half the times I want to put a number 1 in there. So we've done that. Let's go to the slightly more difficult stuff. So the next thing we're going to make is a method called count ones, and what that does is it looks at a particular element. So here it looks at a particular element such as this one here that I'm trying to highlight there, and it will look around it at the 8 values. So these three including itself, and these 3, and it will count every time it sees a 1. So for the values I've just looked at there, the return would be 5. So I've got to try and make that. Okay, so I'm going to do that now, and I'm just going to do system.out.print line, and I'm immediately going to call count, and it was called count ones. And it will take the array. It has to take the array, of course. And the other thing it will take is the R and the C values. So I will temporarily, just for testing purposes, I will use 4, 0. Okay. So I know what I'm going to pass in here. I've got this ready for testing. Next thing I need to do is I need to make a method to action this. So I'm going to do private static. This will return an integer, and it's called count ones. It takes in an int array, which I'm going to call R, and it takes an integer called the letter R, and another integer called C. And what it should do is it should return a count. So I'm going to declare a count equal to 0. And then what I'm going to do here, now I'm going to do something which has got a kind of mistake in it, but that's okay. Right, so what I want to do is I want to look at the surrounding items to the left and to the right. So to the left is -1. So to go to the left, to go 1 away from it, you go -1, and then you go I is less than 2. So that's me going from -1 to 0 to 1. So I'm going to change the value that I'm looking at. I'm going to change R by this value here. Okay, so in actual fact, the row, I will go up 1 in the position and down 1. And now what I need to do is I need to increment that. And then I'm going to do my internal one. So the whole purpose of this is so that I can identify, I can automatically identify 9 positions, and that's what this will do. Okay, so here, if you thought, well, I don't quite understand this, well, I could just go system.out.println, and here I'm going to print out I equals plus I, and then I'm going to do J equals plus J. And this, the whole purpose of this is just to show me that it works. I'm going to put a semicolon there, and now here, to allow me to get it to work, I'm actually going to have to do a return here. So I'm just going to do a temporary return. I'm just going to return count. I will be returning count anyway, but it will be 0. But the purpose of this is so that it could show me all the different positions that happen here. Okay, so I will be adjusting my row and column by -1, -1, -1, 0, -1, 1, 0, -1, and so on. And so you can see by putting in a value for R and C, I could adjust it to create the 9 different values, which are the central value, and that's where we have 0, 0. Okay, and I'm just going to run this again so it's tidier. So here it would give me the central value, and then it would give me all the values around it. Okay, So sometimes I put in print line statements just to help me understand. But in actual fact, what I'm doing here is I'm not doing that. I'm going to say if, and this bit can be a bit tricky. Okay, so if the array value at r plus I c plus j is equal to 1, then I will increment the count. Okay, so the whole idea here was this nested loop. Okay, so the whole purpose of this nested loop is to alter the R and C to interrogate all 9 positions. Okay, so this is a fairly decent way of doing that, and we'll see if it works. So I'm going to run it. As I said before, it does have there is an error in here, which I know about, and we'll be talking about that. Okay, well, okay, so there's an error straight away, which is the fact that I've made a mistake, and it says on line 42 I've got an error, so I need to go and fix that. Yeah, so here line 42, I need to scroll down. I just need to make sure I've got this right. So array and here. Right. Yeah, so I am showing you the error straight away. So I need to change this, and I will test it with something at position 6 here. So it's 4, 6. And I'm going to run that again. And at position 4, 6, apparently there's 3. Now if I look at position 4, 6, okay, and I'm going to try and zoom in a little bit, okay, and make this as big as I can so you can see it. So at position 4, 6, so there's the 0th position, 1, 2, 3, 4. I'm highlighting now the 4th row. Yeah, it's actually the 5th row because we start counting at 0. And then 4, 6, so that would be 0, 1, 2, 3, 4, 5, 6. So this is 6. This is position 6 here, 4, 6. And I'm highlighting it. You should just be able to see that it's gone a little bit darker grey. And here, according to my maths, it's saying that there's 3 items in there, 3 ones, and that's true. If I run it again to test it again, then here I'm going to scroll down to the bottom. It says 5 this time, so I'm going to go down to 4, 6, and 4, 6, 0, 1, 2, 3, 4, 5, 6, and here there's 1, there's 2 here, and there's 5. So that should be 5, and it is 5. Yeah, and you could test that a few times. So that works. So I've got that working. So why did it break earlier on? Well, if I change that to a 0, it will break because it will go out of bounds. And the reason it goes out of bounds is because here I'm trying to interrogate as position 0, which is on the edge. And unfortunately, what this will do, and I'm just going to zoom out again a tiny bit. And what this will do is it will try to, here we go, it will try to subtract 1 from that and interrogate an array position of array -1 and so on. And it can't do that. So unfortunately, before this, we have to check that we are in range. Okay, so we are in range for that value, and I'm going to call it in range. So I'm going to make a helper function. If we are in range for R and in range for C, and the way this does this is if that value there is less than 0 or greater than 19, it will say no. If this one is less than 0 or greater than 19, it will say no, and it will not compute past that, so that will work. Now this, I'm doing this intentionally a little bit sort of weaker than it should be. I should really be passing in another value to indicate the maximum size, the maximum length here. and I'm not doing that just now. Perhaps I could, in fact, but yeah, okay, I will. So here I'm going to pass in the array length as the first parameter, okay, and on this one I'm going to pass in the array length at position C. Okay, and what we're actually testing, we're not testing R, we're testing R plus I and C plus J. Okay, we're testing C plus J because R and C are fine at 4, 0 or something, but we're testing it when we're subtracting 1 from it, is it still within bounds? And so that's what we're going to do here. So that should be fine. Now I need to make the method itself. Okay, so this is private static, and what does it return? It returns a boolean, and it is called inRange, and we have one integer which is, and I'm going to call it the length, and another integer which is the value. Okay, and what I'm going to return is, I'm going to return value is greater than or equal to 0 and value is less than length. Okay, that will ensure that we're not going to interrogate something which is on the left hand side of the array, if you like, less than 0, or anything that is greater than or equal to the length, because that would be out of bounds as well. And that will hopefully stop us getting this error. Now it just says value there, and you might think, well, value, what's that? But value in this case is R plus I or C plus J. Okay, so we'll run that and see if it works. And there we go, that works. That's given me a 5, and I could test that again. And so here it's giving me a 3. Now on this occasion I am testing 4, 0. So 4, 0 is 0, 1, 2, 3, 4, 0. So it's this one here, and it should just be counting these two, and these two, and that's the number 3, and that's correct. If I'm going to test it really dramatically, I could go 0, 0, and hopefully this will work. And so here it's testing that position there, which is 0, 0, and it's going to test all the neighboring elements. So there's just 1 there. I'm going to run it again. 2 this time, so that makes sense. Yep, and that tells me it works. I could test 19, 19 if I'm being really thorough. And 19, 19 is this one down here, and there's 2 elements there. I feel fairly confident that I've got that right, and so I did that for testing purposes. So I'm just going to comment that out just now. Next thing it says is basically we've got to write something called find best. Okay, find best will find the element which has got the greatest number of ones surrounding it. So the maximum number it could be is 9. Okay, so once again I'm just going to do a system out print line. Find best. In fact, I'm going to change that just as per the instructions that are there. I'm going to actually make a new int array called best. I'm going to set that to be -1, -1. And if you remember, you can immediately declare an int array like this, just using these curly brackets. So this is a one-dimensional array, it's got 2 things in it. So this is a little bit equivalent to equals new int 2, like that, but the only difference is, so that would be 0, 0, and the one that I've got is -1, -1. The reason I've got -1, -1 is because I want to have illegal coordinates there, if you like. And this is a new array, and the 0 position will be equal to the R, and the 1 position will be equal to the C. So this is going to be used to store my the outcome. And now I'm going to do best find find best, and I'm going to pass in the array and best, and then I'm going to print out the array. I'm just going to print it directly using the toString method. So now I need to make find best, and it's not as difficult as you might imagine. You've done the difficult stuff. So private static, it doesn't return anything. You would class this as a procedure, find best, and I'm going to pass in a two-dimensional array called R, and I'm going to pass in a one-dimensional array, and I'm going to call it best. I'm going to start with count equal to 0, and I'm going to have to iterate through the rows and columns. Now if you were doing this in NetBeans, it'd be quicker because you could use autocomplete and so on. Which is why I'm not doing it in NetBeans, because I want to reinforce the learning of having to type things out a little bit more. And here, what I'm going to do is, so that is the count, is that right? In fact, that should be called best, because best, we're after best here. And I'm going to do int temp as well. And so here, I'm going to say that temp is equal to find best, sorry, temp is equal to count ones I, j, and that will find how many are surrounding that position. And now I need to say if temp is greater than best, then best is equal to temp. We update temp, but then also we will, and that's a really bad name because here I've got two things called best. So I think I'm going to rename that to count. That'd be a really silly thing to have an integer and an integer array with the same name. So let me change that one as well. Once again, in NetBeans you could do that quicker. So count is 0. If temp is greater than count, count is equal to temp. And then also I'm going to make best 0 equal to I, and best j equal to, sorry, best 1 equal to j, and that will capture the coordinates of that position. Now finally here I'm going to say if the count is equal to 9, if the count is equal to 9, then we stop there. And so what I'll do is I'll just do a return, and that will take us back to the main program. Okay, so we've got that. I'm going to try and run it. Oh, I've got some errors. Temp equals count 1. Ah, right, so I've forgotten to, so when we're doing the count, we need to pass in the array. I'm going to run that again. And I've got an error here, and that's because I'm using arrays, but I've not imported it. So I'm going to import java.util.everything. I'm going to run that. and that should work. So here you can see, run it again, and according to this, at position 7.1, it's got the greatest number of values. Now I'm just going to change my final print screen here. I'm just going to say here at, I should say my final printout at position, then I'll concatenate that there are, and then I'm going to do count ones. I'm going to use R, and then I will use best 0. And so here what I'm doing is I'm going to do a count ones at that point, just so as I can indicate that. I'll run that again. Okay, so at position 5.18, I'm going to do that again at a position that's easier for me to get to. At position 2.14, there's 8, and I'm going to run it a couple of times. Right, okay, at position 1.3, there are 8. Okay, so at position 1.3, it says there's 8, and so I'm going to go to row 1, which is here. Position 3 is here. So there, yeah, I can see straight away that there's only one missing there, and so there's 8. So that works. So let's just have another look at the code. So the methods that we've created, the first thing we did was we declared and instantiated a two-dimensional array. Then we've got a print method here, nice simple print method with the nested for loop, and I've used a tab and a print line at the end. Then I've got populating the array, and I did that using math.random. Obviously only populating ones because zeros are there already, so if you had an else statement there, you've wasted a bit of computational power. Then I've got count ones, and now count ones was reasonably easy, apart from the fact that you have to identify when we go outside the limits of the array. Array out of index is a common error. Then in range here, in range, there's other ways to do this. This looks fine to me just now. And then find best, once again, we iterate through every position. We count the ones at every single position, and we will update the best count, if you like, based on that, and update the array that contains those values. This is a void because here it's going to update this array here by reference, so passing by reference. We've got this bit here because I did say in the problem descriptor, if you encounter 9, then straight away you're never going to beat that, and that's the first instance of that, so we would just return. So it's using a return just to break us back out of here into the main method. I hope this helped. Review your code and yeah, redo the problem if you need to. Good stuff. Catch you later.